Hello, welcome everybody to channel Sube. Today I am going to explain you how to solve this problem, question number 35 of 2020 physics paper MCQ part. What is the maximum mass of ice at -5 centigrade that can be completely dissolved in 1 kilogram of water at 35 centigrade in a container with negligible heat capacity? Let the specific heat capacities of ice and water be 2 times 10 power 3 joule and 4 times 10 power 3 joule respectively, and the specific latent heat of fusion of ice be 3.4 times 10 power 5 joule per kilogram. Assume there is no exchange of heat with the surrounding. 200 gram, 240 gram, 300 gram, 360 gram, 400 gram. This method is called method of mixture in physics. The ice cube has been dropped into water so that completely dissolve it. For your sake, for you to understand easily, I draw a diagram. This one is the ice, cube of ice, -5 temperature. Mass we don't know. Specific heat is given 2 times 10 power 3. Latent heat of fusion is given, specific latent heat of fusion is given 3.4 10 power 3, 10 power 5. Be careful, sometimes they give it in kilojoule, here joule, here also joule, no kilojoule is given. Sometimes they give in kilojoule. So this is the piece of ice. So this one is solid state. Then water is given in a container whose temperature is 35. Mass is 1 kilogram. Specific heat capacity is 4 times 10 power 3. Then what they have done, put this piece of ice in, drop this piece of ice into this water and mix it perfectly until the piece of ice completely dissolves. So we have to find out the mass of ice. This is what we have to find. So in this types of questions, first we have to identify who gives heat, and who absorbs. Whose temperature is higher? In this case, this one. Whose temperature is higher gives heat away. Here, water gives or emits heat. Donate. Then if someone's temperature is lower, what happens? It absorbs heat. So here in this case, ice absorbs heat. Then we know who gives and who absorbs. But regarding the cube of ice, we have to think about what happens when we put this piece of ice into water. We put this ice into water and mix it. Then final situation we should visualize in our mind. So I draw. The water is there. Finally, when ice is introduced into this container and dissolved totally, this water become 0 centigrade, and the ice came from outside is now liquid form. It is here as liquid whose temperature is 0. This system is at equilibrium condition. So no temperature is furthermore change. Therefore, finally what happens? The ice cube becomes liquid state. Earlier it was solid state. Finally it converted into liquid state, change of state. So regarding ice, we can divide it into the path into two parts. Initially the cube of ice, the solid change temperature, only the temperature from -5 to 0 centigrade. Still this one is solid, that means ice, solid. Then it converts to liquid state, water. Temperature is 0. Water of 0 temperature, 0 centigrade. So this one liquid. So in this part what happened? Solid state changed to liquid state. That means change of state. So the heat absorbs is called latent heat capacity, specific latent heat of fusion. It is given. That is denoted by capital L. So here the equation is Q equals mL, because no temperature change. Here 0, here 0. Then theta is not there in this equation. This part does not participate in change of state. So the equation is then Q equals ms theta. So this amount of heat ice absorbs, this amount of heat ice absorbs. Then what happened to water? From here water change only its temperature, not state. Then we have to write Q equals ms theta. That is the only thing happened to, that happened to water. This amount of heat gives away. Away means to ice. Then we can write the final equation, conservation of energy. The heat gave must equal to heat absorbed, because no heat is lost. Assume there is no exchange of heat with the surrounding, only heat exchange with this water and cube of ice. So heat gave, who gave heat? Water, only ms theta part. Then m water, s water, theta water. That's only for left side. Heat absorbed, these both equations we have to write. Ms theta of ice immense theta of ice plus ml of ice. Now we can substitute values. M of water is 1 kilogram, so we don't have to write it. S of water is 4 times 10 power 3. The temperature change of water is how much? From 35 to, initially it was at 35 centigrade, finally it was at 0 centigrade. So 35 degrees here. 35 degrees equals now M ice, that we don't know. S of ice is given 2 times 10 power 3. Then plus again M temperature difference now times ice initially at -5. For this part finally 0. Then 5 centigrades, 5 degrees. Then plus here M of ice we don't know, that's what we have to find out. L now is 3.4 times 10 power 3, 10 power 5. So here 10 power 3, here 10 power 3. Therefore I convert this thing instead of 3.4, 340 times 10 power 3. 2 decimal places, then 5 became 3. So now we can cancel 10 power 3 in every parts, cancel it. Then 4 times, don't simplify this thing in MCQ questions. So here 2 times 5, 10 times simple M, plus here 340 times M. So we can add 340 to 10, 350 times M, here 4 times 35. So we can simplify, divide by 35, 1, 10. Then 10M equals 4, then M equals 4 divided by 10 means 0.4 kilogram, but answers are given in gram, so 400 gram. When you say gram or kilogram units, don't say plural, it is wrong. The rule is all the units are singular, no plural. 400 gram. If you say 400 grams, it is wrong. The 0.4 kilograms, it is wrong. That is basic about units. If you have learned the first lesson properly, you know these things. I have heard some people say 400 grams, even teachers, that is wrong. You can go to the standard websites about units, what we call Wikipedia. Go and see that page about units. There is a place at the close to bottom. You have to go to 4/3 about of that page. There clearly it is denoted. Clearly denoted no plural, only singular. That is a rule. So 400 gram. Now the answer must be then this one, 400 gram. So I think you understood how we solved this question. Thank you very much for watching this video. Now you know what you have to do before you leave the page. Thank you very much. See you again. Goodbye.